Hello, I'm Robin Cole, and welcome to the Satellite Image Deep Learning Podcast. In this episode, I caught up with Caleb Robinson to learn about the Building Damage Assessment Toolkit from the Microsoft AI for Good lab. This toolkit enables first responders to carry out an end-to-end workflow for assessing damage to buildings after natural disasters using post-disaster satellite imagery. It includes tools for annotating imagery, fine-tuning deep learning models, and visualizing model predictions on a map. Caleb shared an example where an organization was able to train a useful model with just 100 annotations and complete the entire workflow in half a day. I believe this represents a significant new capability, enabling more rapid response in times of crisis. If you're watching this on YouTube, please consider liking the video and subscribing to the channel, as this really helps to reach a wider audience. Thank you. Hi, Caleb. Welcome back to the podcast.
Awesome. Thanks for having me, Robin. Good to be here again.
Fantastic. So today we're going to be talking about damage assessment in the context of disasters. Why don't you tell me what you've been up to?
Yeah, so principal research scientist at Microsoft on the AI for Good team. One of our big focus areas is doing disaster response work. And over the past couple of years, throughout responding to many disasters around the world, we've developed this building damage assessment toolkit. And it's really a workflow that allows people to reproduce the damage assessments that we do quickly using post-disaster optical satellite imagery.
Right, so this is RGB imagery, typically captured a day or so after the actual kind of disaster event.
Yeah, and it can be RGB, it can be multispectral. It's really the pipeline itself is really agnostic to the type of imagery or the provider of the imagery. The whole point of it is to be able to train a model to the specific disaster that has happened, run the model over all of the imagery covering that particular area, and then get the results to a partner as quickly as possible.
Right, so models trained for specific events.
Mm-hmm.
Producing results very quickly. Fantastic. I know you got a short presentation. Why don't we fire it up and start talking through this workflow?
Cool. So yeah, went through all this. Like I said, we've open sourced this workflow. I think stepping through the code line by line is not particularly interesting, but the point is it's out there on GitHub at github.com/Microsoft/building-damage-assessment. And really this repo, again, gives people step-by-step tutorials to reproduce the work that we've done in responding to different disasters around the world. The demo is how we responded to the wildfires that hit Hawaii, specifically Maui, last August.
Out of curiosity, how many years kind of work has gone into getting to this workflow?
Yeah, good question. We started with the earthquakes in Turkey. If you remember those, I think that was sort of springtime, at least in the Northern Hemisphere for 2022. And we've sort of been iterating on this process ever since.
Right, so it's gone through quite a bit of refinement over a couple of years then.
Yeah, this is the kind of the basic problem setup. You assume that you're given sort of post-event high resolution satellite or aerial imagery, it's agnostic. Here you can see kind of visual signs of damage of the disaster in the imagery. And our goal is always to do these building levels assessments of damage. We want to summarize for each building footprint whether or not we think it's damaged, and for some types of disasters, how damaged we think it is.
Mm-hmm.
And I really describe kind of the purpose of making this a workflow using this chart. So here you have on the x-axis number of hours after a disaster, y-axis number of buildings that have been assessed as damaged or not. The goal is, of course, to get to 100% of buildings assessed, and you want to do that as quickly as possible. And when we started off with this work, we were trying to train these models that would work under any conditions. And that really led us to this red line here, which is the model doesn't work workflow. You have this model, you get imagery from a new disaster, you try to run it, and the results just aren't where they need to be. And here you really don't have the time in disaster response scenarios to turn it into a research project and maybe try domain adaptation methods. you're just not going to get to that 100% damage assessment result with the quality that you need to ship out to the first responders. And really, in that scenario, your time would be better spent with this blue line, doing a manual labeling of the buildings. You go one by one, maybe do 10 seconds per building, and you can eventually get to that 100% line. And really where we want to be is this green line, which is a human in the loop workflow where human labelers, domain experts, people can tune the models for a specific disaster and have this like low variance way of getting results reliably and of good quality.
Yeah.
And for an example of why a lot of the ways that you train will end up in this red zone, I've just got a couple examples of post-disaster imagery. This is not post-disaster. This is aerial imagery of the Microsoft campus, and it's really high quality, high resolution, really no artifacts. But when you get into imagery captured after disaster, it's often off nadir. There might be artifacts, different lighting conditions, and your model has to deal with all of these scenarios if it's going to be this general purpose thing. And we often don't have labels for all these scenarios, so such a model is very hard to train.
Right.
So here I'm just flicking through some of the images that we actually had to deal with in the Turkey earthquake response.
So these are from different satellites, different times of day, different positions.
Exactly. And even Mosaic, all of them, really shows how you have to deal with these different conditions, different times of day, clouds, artifacts. Your model has to work over all of these variety of conditions, no matter what, because the important thing here is getting the results out. So that really led us to this workflow that's implemented in that GitHub repo from the first slide, and it couldn't be more simple. Here, the steps are: you set up this labeling tool with post-disaster imagery. That's a different open source project that we have. This satellite imagery labeling tool is a very lightweight way to create polygon labels over pretty much any imagery that can be served in XYZ tile format. And then just repeat the steps of annotating examples of buildings, damaged buildings, background class, and occasionally clouds, depending on the quality of your scene. Fine-tuning a model from scratch and evaluating that performance on a held-out validation set. And if you just repeat this for a couple of iterations, we found that you're often getting really, really good performance with a small number of labels. So here's an example of Rolling Fork, Mississippi. There was a tornado that hit this town, and we partnered with American Red Cross in order to do a disaster response here. So for training, we did 153 polygon annotations spread again between the background, undamaged building, and damaged building classes. Tuned a UNet with basic ImageNet pre-training setup. All of this was implemented with TorchGeo. And this is the results that you get after maybe like 30 minutes of fine-tuning the model.
So let me just check. So that is literally representing the number of annotations that this model was trained on, that scene there. Approximately.
Yeah, 100 annotations.
Yeah.
And this is what you're seeing now is the output of those 100 annotations summarized over the building footprints, existing kind of post or pre-disaster building footprints for this location.
And is this model, is it just trained from scratch, or it's been trained on other disaster situations?
No, just trained from an ImageNet initialization.
Okay, from scratch, right.
Yep. And kind of the surprising thing here is that you only need kind of 150 labels, as the point of this model isn't to be a general purpose disaster response model. It's to get good annotations for this specific scene over Rolling Fork, Mississippi. And once that's your goal, the number of labels that you need really, really decreases.
On the technical side, do you have to do lots of augmentation to get good results, or is it pretty much just it's a very kind of consistent scene, so it's not that difficult a task?
Yeah, it's a consistent scene, so it's not that difficult of a task. I think there's augmentation built into the workflow, but I would be surprised if that was a necessary component. And of course, there's a lot of room for research work and improvement here? Like, is there just a lightweight, self-supervised way that you can initialize a model specific for this scene, for example, or specific for the sensor? So you do have a better starting point than ImageNet. But like again, 150 labels is not that much of a effort from an annotation standpoint. If it can get you to a good point, then that's something that we can work with.
Yeah. So if you had a very large image, you might only annotate sort of 10% of it and then apply this model to the remaining 90% and see good results.
Yeah, and that's exactly the workflow. So we usually start off with a very local part of the image where we know that there are examples of that disaster class. And then after the first iteration, if the results are not working well somewhere else in the image, we'll jump and label a little bit there.
Mm-hmm.
So that's that iterative feedback that you get from just kind of looking at the predictions or labeling randomly for a validation set is what drives the stopping criteria there.
I might be jumping the gun here, but do you visualize the predictions of the model on the same tool while you're annotating, so you can kind of have a single place where you do the entire workflow?
Not the same tool, but the inputs and outputs of the workflow are GeoTIFF, so it's quite easy to drop into QGIS, your favorite GIS software.
Yeah,
that's our standard way of approaching it. So for this disaster, specifically, the American Red Cross was on the ground here, and they collected 909 ground truth labels from actually going door to door and inspecting damage. And if you compare our model with that, we see we get 96% average precision here.
Mm-hmm.
We did the same thing for the wildfires in Maui. Here, only 108 annotations were needed. We happened to stop after that. From a selection of 250 random building footprints that we annotated based on just interpreting the imagery, 99% recall and 96% precision on the damaged or not damaged task. Mm-hmm. And this whole thing end-to-end was just 4 hours for the Maui response. Mm-hmm. And this can actually have impact in the world. So at the AI for Good Lab, our goal really is to make impact. And here we were able to see that the American Red Cross was able to use this to speed up their kind of damage assessment process, which is a requirement for them to release funds to people who need it. Same thing with Maui United Way. They used these outputs to actually generate receipts for aid disbursement that they were doing on ground. And I just wanted to end off here with a visualizer that we made just last week for the floods that hit Valencia, Spain. Mm-hmm. So real-time output from our model here. This is the visualizer, and we usually create these to share with partners that we have. But here, instead of building damage assessment, we're doing flood extent mapping, but it's the exact same workflow. So instead of labeling actually buildings as damaged, you attempt to label where you see flood extent. And here, this is just a typical pre-post map where you can see what things look like in base map, what things look like in the post-disaster imagery. Mm. And then the model predictions. So red is flood extent, gray is clouds. There's some places here that were really, really hit hard, particularly along the rivers. So if you zoom in here, I think this was a big parking lot. It's along the dry riverbed. And then here you can see the floodwaters kind of wiped out half.
Yeah, really great results.
And again, this is like 200 labels, a couple hours worth of work to produce this. And then you can run this analysis on a much, much larger scene. If you had PlanetScope imagery kind of extending past this, I would expect the same model to work in that scenario. So it really mm-hmm. saves a lot of time when you're doing these responses.
Yeah, I mean, getting the sort of output in half a day is just stunning, and really flies against typical expectations about how time consuming these projects can be.
Yeah, yeah. So yeah, like I said, the repository actually has step-by-step instructions where you can reproduce the work that we did in Maui. We also look at how to do flood extent mapping from SAR imagery. There's a lot of great work that's been done in the community here. But yeah, we hope people will contribute to this repo, and we'll definitely contribute to it as we work through more of these disasters.
Fantastic. Well, thank you so much for the walkthrough. One final question. You mentioned you've been working on this for 2 years. I'm wondering what you feel like you've learned in the process of that process.
Yeah, a lot. So always working with domain experts, whether it's in disaster response or other topics, you learn a lot about how the responses are actually executed, what types of damage you should be looking through in the image. Sometimes that's down trees, sometimes that's flood extent, debris, what buildings are actually important for responses after like hurricanes. Not all building footprints are relevant for kind of calibrating the level of response. You're really looking for residential areas. So sheds, for example, are important to include. Yeah, the list goes on and on. From a technical side, it's about how to create again these like low variance workflows that allow you to get good results consistently, and not have cases where your model is just outputting things that you can't ship.
Yeah. And of course, this workflow can be adapted for non-disaster tasks as well.
Yeah,
Yeah, fantastic. Okay, well, it's been brilliant having you on again. I think we'll do a third one in the future, but for now, thank you for joining me and all the best.
thanks so much, Robin. You too.